So we've got, the first thing we need to realize when we talk about counting and representing real numbers is what happens in base 10. So in base 10, this is what happens. We have our whole number part, so the whole number part is here. Okay, and that's powers of 10. So we go down to powers of 10, which is 0. So we've got units. Okay, we've got units here, which are ones. We've got tens, then we've got hundreds, and then we've got thousands. And that's what happens. But when we get the binary point, or the decimal point, sorry, when we get the decimal point, we turn into fractions. And the fractions themselves, you'll see, we go a tenth, and then a hundredth, and then a thousandth, and then a 10,000th. Okay, and that's how they work. In terms of number bases, what we've got is we've got 10 to the minus 1, 10 to the minus 2, 10 to the minus 3, and 10 to the minus 4. So this progression here of number of the exponents continues. So we get 3, 2, 1, 0, minus 1, minus 2, minus 3, minus 4. So that's the progression down. And obviously these represent values. So we know that if we wrote, let's write a value in here. So if we write with 1000, no hundreds, and let's have 3 tens and 4 ones, then we get 1034. Now when we carry on into the decimals, then if we put 2 tenths, so that's 0.2. If we put 4 hundredths, and then 6 thousandths, and 7 10,000ths, that's the number we get. So our number becomes 1034.2467. Now, so we do the same with base 2. So let's just have a look at base 2. So if we bring in the base 2 here, now again it's the same. So we've still got our progression here of our exponents. So we've got 3, 2, 1, 0, and then we've got minus 2 to the minus 1, 2 to the minus 2, 2 to the minus 3, 2 to the minus 4. Okay, so this time the fractions are 1 over 2, 1 over 4, 1 over 8, and 1 over 16. Okay, and if we work those out, if we actually do the division, then we get these numbers here. We get 0.5 is 1 over 2, 0.25, 0.125, and 0.0625 for 1/16. Okay, we can do those divisions, you can work those out, but that's what they are. You need to try and remember those and recognize them. So it works the same as in base 10. Okay, so if I wrote a binary number on the positive side, so let's have an 8, a 4, a I can't do that, a 0, a 1 of them, and 1 of them. Okay, so I've got 11 here because I've got a 1, 8, a 2, and a 1, so that makes 11. So it's 8 plus 2 is 2 is 10, plus 1 is 11. Now what happens for the binary? So we do exactly the same. So if I put a 1 in this column here, that means it's a half. Okay, so if I do that, that is a half. If I add to it a quarter, I add them up, 0.5 and 0.25. I don't want any 8ths, I'll have a 16th though. Okay, so I get the number 0.8125 by adding up these decimal values here. So I've added 0.5, 0.25 and 0.625. I've added them up and then that's the number I get. So my total value will be 11.8125, and that's how we work with real numbers in Denary. This is called fixed point binary because the binary point is always fixed in this case. In this case we've got 4 bits before the binary point and 4 bits after the binary point, but it could change. You'll be told what is occurring.